All right, this is lesson 5.1a. It's an introduction to functions. This first problem says that Jason is spending the week fishing at Springville Fish Hatchery. Each day he catches 3 fish for each hour he spends fishing. This relationship can be modeled by the equation y equals 3x, where x is the number of hours spent fishing and y is the number of fish caught. So let's complete the table using this equation. Let me get a blue pen, purple pen. All right, so all you do in the equation is it gives you x, so you plug in 3 for x. So 3 times 3 is 9. So y, or the number of fish caught, after 3 hours is 9. So these aren't in sequential order, so they kind of make it impossible for you to see a pattern. So 2, you're going to plug in 3 times 2, which is 6. For 1, you're going to plug in 1 where the x is, so y equals 3. And then there's another 6. If he doesn't fish, he doesn't catch any. And then we're going to plug in 4. So 3 times 4 is 12. Okay. So we are going to put the number of hours fishing on the x, hours fishing, and then the number of fish on the y. So I'm going to pause here and plot so we don't eat up all our time plotting. You can stop the video too and plot all of these points on the graph. Okay. So when you plot all these points on the graph, let me erase all my work over here so we can see the writing that came up on the PowerPoint. Let me erase this stuff. So this is an example of a function, which means the number of fish caught is a function of the hours Jason spends fishing. So this here is a duplicate and it really shouldn't be on there. We talked about what things are when they're functions. That means for every unique x, there's a unique y. Also, if we were to connect the dots here, you would have a straight line. So this is a function. If you would draw a vertical line anywhere on this graph, it would only go through one point. So that's also another reason something is a function. You know what? Let's take a look at something that isn't a function so you can compare the two graphs. So Sean, he's also spending a week fishing. However, he is fishing in Bear River. Each day he records how many hours he spends fishing and how many fish that he caught. So let's look at this. This is already filled in for us. So I'm going to take a minute, pause the video, and I'm going to label the graph with same way as the other one. So this is the x will be hours and the y will be number of fish caught. So I'm going to go up by intervals of 1. So I'm going to take a minute and label my graph, and you can do the same. And I will see you in a minute. So if you take a look at this, this is an example of a relation that is not a function. So if you're looking at the table of values and you see that you have a repeating x value, that's one tip off that this is not a function. But if you look at the graph and you see if I draw a vertical line right here, it crosses 2 points. If a vertical line drawn anywhere on that graph crosses more than 1 point, this is not a function. That means that the hours that he spent fishing are really no prediction of the number of fish that he caught. All right, let's move on. Let's compare and contrast the relationships. Like now we're going to put the tables right next to each other. And we're going to make an educated guess about what kind of relationship makes a function. We already kind of talked about this. So This is Jason here, the first one, and then you have, I forgot what his name was, Sean, okay? So if you look here, this shouldn't be on here. Look at the tables. There are no X values that repeat here. They're all the same. But here in Sean's table, like I showed you before, there are 2 3s in that table. So if you just had the tables, you could tell by looking at them that it's not a function. Sean is not. And also here I showed you if you drew a vertical line on any place, if it crosses through 2 points, it's not a function. So it's a nice visual to see that right next to each other. Okay? So let's look at the next one. Vanessa is buying gumballs at Vincent's drugstore. The mapping below, this is a mapping right here. This is called a mapping. Shows the relationship between the number of pennies or X she puts into the machine and the number of gumballs she gets out, or Y. So we're going to take that mapping and we're going to put it onto a table. So we just transfer the X's over here. 1, 2, 3, 4. That's the number of gumballs. We're going to transfer the Y's. So 1 is paired up with 2. That arrow tells you what it's paired with. 2 is paired up with 4. 3 is paired up with 6 right here. This tells you where it's paired. 4 is paired with 8. Okay? So when we plot those, you have 1 penny, 2 gumballs, 2 pennies, 4 gumballs, 3, 6, 4, 8. Okay? See how these things are related between each other, the relationship between. So now we want to write an equation that goes with this. Okay? So our equation right here is how much for 1. That's our unit rate. If you can find 1 on your table, that's your unit rate, and that's going to be your slope. We're back to that y equals mx plus b. Just when you thought we weren't going to need that anymore, here it is back. Y equals mx plus b. So our unit rate is 2, and we start at 0 pennies, 0 gumballs. So that is our equation for that function. All right. So is this a function? Yes, this is an example of a function because the number of gumballs you get is related to the number of pennies you put in. So for every penny you put in, you get 2 more. It's not just random. In this case, it's not just random. All right, let's move on. Kevin, he goes across town to Marley's drugstore. The mapping diagram below relates the number of pennies he puts into the machine and how many he gets out. So let's just transfer the information from our mapping diagram over here to the table. So 1 is paired up with 2. He put in 1 penny, he got out 2 gumballs. 2 is paired up with 3. 2 again is paired up with 4. So we have twice he put in 2 gumballs, but he got something different out each time. And then 3 is paired with 6. Okay? So let's plot this again. And I already hit the button so you can tell this is not going to be a function, but we should already know that because, oh look, 2 repeats itself in the table. But let's see what that looks like on our graph. So I have 1 and 2, 1 penny, 2 gumballs, 2 pennies, 3. He puts in 2 pennies again, and this time he gets 4, 3, 6. So you can see right here, if I drew a vertical line right there, that's called the vertical line test. It goes through more than 1 point at a time. So that disqualifies it from being a function. If you look at the mapping diagram here, if any of your x's have more than 1 arrow coming from it, that's also a way that you can tell that this isn't a function. All right, moving right along, we got Cody. He's at Ted's drugstore. The graph below relates the number of pennies he puts into the machine on different occasions. So let's explain how this works. Every time Cody puts in 1 gumball, 1 penny, different number of gumballs comes out. So every time Cody puts in a penny, a different number of gumballs comes out. So in this example, is the number of gumballs received a function of the amount of money you put in? Explain your answer. Well, look at my vertical line here. It goes through so many points. So no, this is not a function. It fails the vertical line test. All right, moving right along. All right, let's go to page 14. Skip on to page 14. All the way to number 9. Okay. The cost for entry into a local amusement park is $45. Once inside, you can ride an unlimited number of rides. So it's just like Great America, right? You just pay that one-time fee and then you can keep riding rides. So if I go on 0 rides, I still have to pay that $45. If I go on 1, oh, $45. 2, still $45, and so on. No matter how many times I ride a ride, it's $45. Okay, so let's label this graph. This is going to be the money I spent here, and this is going to be the number of rides. Down here, I'm going to go by 1. And here I'm going to go by 5s. And let's graph this. 0, 45, 1 ride, still 45, 2, 3, 4. I can just go on like that forever because we know it's always going to cost 45. Well, is the amount one spends on a function of the ride she goes on? Why or why not? So look at, if I draw my vertical line like this, it only goes through 1. So this is a function. And if I look at my table, there are no duplicate x's. Also a reason it's a function. All right, let's move on. Number 10, look at this table that shows the number of hours Owen plays his favorite video games and the score he gets. So after 1 hour, he could score 5,000, but still a different hour, he could score 550. Another hour, 6,550. 2 hours, 11,000. So if we look at this table, is the number of points Owen scores a function of the amount of time he spends playing? No, because 1 has several different outputs here. Several outputs. If this was a function, every time you had 1, it would be 1 unique output. You wouldn't have duplicates. So no, 1 hour has multiple outputs. And 2 hours also, look, has multiple outputs. He could score 11,300, and he also scored 12,400. And 2 has multiple outputs. All right, that's it for this section.